Welcome to Study Loop.
Hello everyone, today we're doing chapter 23, problem 64, and this problem asks us to draw two different haloketones that can form A by intramolecular alkylation reaction, and B, synthesize A using acetoacetic ester synthesis. So let's start with A. So let's start with the haloketone. So we can just start with a very simple one. It's one bromine. Then we see that we have to add this entire R group, but we already have an electrophile here, so we need to make this carbon a nucleophile. So the way we can do that is make that into a Grignard. So we can add MgBr, so the Grignard reagent, and then just count your number of carbons that you want to add. So we have 1, 2, 3, 4, 5, and then a 6th carbon, and then we have these 6 here. Now on this side of the 6th carbon, I'm just going to add a bromine. So first thing first, if I react these two, well, this is the carbanion. It's going to do a nucleophilic attack at this position. So then what we're going to be left with is something that looks like this. And now if I add in some sort of strong base, sodium methoxide, that will deprotonate the alpha proton here. It'll deprotonate this to make a carbanion, in which it can go through an SN2 stepwise SN2 nucleophilic attack at this carbon electrophilic carbon here to kick off bromine to now form the final product like this. So this is one way. Another way is that you can actually make both of these carbon nucleophilic by having both of them as Grignard reagents. So MgBr, MgBr, and then you're going to react that with now your ketone, but now it's going to have two halides. So then you can have two nucleophiles attacking the carbon with your two you're leaving groups. So then right away, in one step, you'll get your final product. This reaction will probably be very messy though. I wouldn't recommend doing this in a lab, just because you have very minimal control about what else can go on in this reaction. But these are two possibilities for using the conditions provided in the question of haloketone. But in part B, it asks to do from the acetic acid ester synthesis. So starting from your acetoacetic acid, we can start from the ester version being this. And now we can add a strong base, sodium ethoxide, and then we're going to add our electrophile. That's going to be the carbons that we need to add. So all of these carbons here. And you see how I'm drawing it, that it kind of resembles the shape that I want, so it's easier to count carbons that way. So after one equivalence of this reaction, we will have react with one of these electrophiles. So we will make a carbanion that will hit one of these electrophilic carbon centers to form now this. And then if I react it with another equivalent of base, sodium ethoxide, you'll deprotonate the other second proton here, the alpha proton here, to form a carbanion, which can then go through SN2 backside attack to give us this product here. Like this. And now if I add in acidic water and heat, you would get spontaneous decarboxylation and hydrolysis of our ester to just leave our ketone plus CO2.